okay? So let me remind you of our process. I think what I generally do is I draw a picture to understand the situation. In other words, what is changing, right? What is constant? Okay. So what picture am I talking about here? You know, when I drew this picture over here, I'm trying to show, oh, the radius is getting larger as we inflate this balloon. So this sort of shows that both the volume and the radius are getting bigger. When I looked at this problem involving the plane flying overhead, I drew this sequence of P's. I'm missing a P here, it got deleted somehow. But right, the idea is that the plane is flying. So definitely you can see that this length here is changing. So I gave it a variable. And then this side is not changing. So it's labeled with a constant. And this Z is changing. So we label that with a variable. Okay. And then when we did the rocket ship taking off, what was changing and what's constant? This side of the triangle is changing. So I give it a variable. The angle between the camera and the ground is changing. So I give it a variable. But the distance from the camera to the launching pad was constant. So I gave that a constant. So the first step for me is always trying to draw this picture to really answer these two questions. What is changing and what is constant? Does that make sense for everybody? And I'm going to mimic it with one more example. So the second thing that I want to do is I want to, I draw a schematic diagram labeling. I think of this almost as like a snapshot. And I'm labeling the constants and the variables. So what's this snapshot that I'm talking about here? That's always the picture I draw kind of off to the side. So if you were to look at this, right, after I saw this situation, I can figure out what's changing and what's constant. Then I just take a snapshot of like one of these particular triangles and I label the variables and I label the constants, right? Same thing over here. I had these triangles changing. I took a snapshot. I labeled the variables. I labeled the constants, right? And I didn't do it for this first one just because I didn't, but I could. I could just put a circle like this, put the radius like this, and then that's like a side view of a sphere, you know? So maybe I should have done that. Okay. So after that, I always try to translate what rates are they giving us? You know, I also want to know, what are we looking for? I realize that I'm repeating myself because I've told you all of this already, but I'm just trying to sort of set the method for you. So when I do my final example, it'll be like, oh yeah, we've done this 4 times already. Okay. So when I look at our worksheet over here, what rate did they give us? They gave us this rate. What rate are we looking for? We're looking for this rate. I'm always trying to identify those two things. What rate did they give us? They gave me how fast the plane was flying. What rate are we looking for? We're looking for the distance, the rate of change of the distance between the man and the plane, right? Over here, what rate did they give us? They gave us the how, the speed of the rocket. What are we looking for? We're looking for the rate of change of the angle. So all of these guys kind of follow the same pattern. The next thing that I try to do is I try to relate the variables. And this part is the part where I talk about making a model. Right? So I really wanted to list the different models that we've experienced so far. This is not a comprehensive list, but it's a representative list, I guess. So the first one we'd have is some sort of well-known geometric situation. What would some examples be? Volume of a sphere. That's our earlier example. You could have volume of a cone or a box or a cylinder. These are all situations that says cone. I don't know if you can read that. Cone. So, I mean, these are situations that are well known in general. Maybe they're not well known by you, but the volume of a sphere is V is equal to 4/3 pi r cubed. The volume of a cone is equal to 1/3 pi r squared h. The volume of a box is equal to length times width times height. The volume of a cylinder is equal to pi r squared times h. I could give you these formulas on a quiz, but I can't tell you which one to use, so I think I don't mind giving you these formulas, but you would have to recognize which one is which. So these are all pretty common models that we have. Okay. And that was really example one, was what I had done there. What's another common model that we have? We have Pythagorean theorem. This is very common. And that basically says the longest side z squared is equal to x squared plus y squared. So this is the longest side. This is the hypotenuse. Okay. That was example two. And then what's another model that we saw? We saw we could have a right triangle trigonometry. So right triangle trigonometry, that's going to look something like all the SOHCAHTOA stuff. Right? So if you have a right triangle, and you have the angle theta here, they could give you two of the sides, and then that would give you some sort of trigonometric relationship. Does that make sense? So our example three worked that way. So if I look at these examples, this is the geometric one because I related the variables with the volume of a sphere. This one was the Pythagorean theorem. There's no angles involved. It's three sides. So that's how you know you have the Pythagorean theorem. This one, two sides and an angle. That tells you that you want to use a trigonometric relationship. And today we're going to look at one other one. So let me pause here. Is there any questions about my process so far? This section is always one of the hardest sections to teach. And it's one of the sections students have difficulty with. So I'm kind of continually changing how I try to teach it. And I'm really emphasizing creating models. And I want to tell you about the fourth type of model we have. So did anyone have any questions for me? No questions. All right. So So the other type of relationship that we have is something called similar triangles. And similar triangles is all about proportions. Okay. So I'm going to draw a couple of pictures. One picture I'm going to draw is something that looks like this. Okay, and then I can kind of slice it like this right here. And I'm going to take this picture, I'm going to copy it, and I'm going to put it over here as well. And then I'm going to rotate it. Okay. Because I want you to see something. So one thing I could do is I could come over here, I could say, I could call this length x1, and I can call this larger length x2. I can call this length here y1. I can call this length here y2. And the proportional relationship that we have looks something like this. The ratio of this side to this side is going to be the same as the ratio of this side to this side. So if I wrote that as a fraction, that would be x1 over y1 is going to be the same as x2 over y2. Does that make sense to you? In other words, this triangle right here is just a smaller version with the same proportions as this triangle right here. So it's kind of like people that are really into cars. Sometimes they like to have these like miniature models of a car that they love. So they have the same car, but it's scaled down to like 1/32 of the size of the original vehicle. And then it's, it's like a replica. And that's the same idea. It's like this big thing is like the big car, and the smaller thing is like the replica. And it satisfies this proportional relationship. Does anybody have any questions about that? So I can do the same thing vertically over here. How you label things is up to you. My tendency is to label horizontal things with X and vertical things with Y. So I could go X1 and then Y1 like this. I could go X2 and then Y2 like this. We still have the same relationship, right? X1 over Y1 is going to be equal to X2 over Y2. We're still comparing those proportions and saying that those two proportions should be equal to each other. The only difference is that this picture is oriented vertically and this picture is oriented horizontally. Any questions about that? Okay. So why don't we do this last example over here?